Hey everyone. In this video, I'm going to talk about predicting the US presidential election. So in the last video, we talked about combining polling averages to compute kind of the predicted popular vote results or popular vote support for Biden versus Trump in this upcoming 2020 election. And of course, ultimately, the popular vote is not what decides who's going to be president in the United States. What is decisive ultimately is the Electoral College, right? And they're of course going back to 2016 or further back to the 2000 election between Bush and Gore. There have been instances where a presidential candidate did not win the majority of the popular vote, but nevertheless was elected president through the Electoral College, right? So how do you win the Electoral College? You have to win the absolute majority of 538 electoral votes. These 538 electoral votes are made up of 435 seats that are allocated just like the representatives in the House of Representatives, plus 100 senatorial seats. So each state gets 2 additional seats, plus 3 additional electors for the District of Columbia, so Washington, D.C. So that makes 538, and of course, that implies that smaller states with smaller populations who have lower proportion of members of the House, but still have 2 senators, are ultimately overrepresented in the Electoral College, right? So there's some bias towards smaller states here. In order to become president, you have to win at least 270 votes in the Electoral College, and if nobody wins the absolute majority, then ultimately the House of Representatives will decide on the next president, right? So in order to predict the winner of or provide a prediction of who's going to win the next election, we must predict the winner of each state, okay? So in order to do that, we will again use our 2020 polling data. This is just an overview where we have, as I said, information on individual polls that were conducted over time. Some of these polls were conducted specifically with a given state in mind, like Iowa, Nevada, Michigan, Wisconsin, and so on. And each of those polls have support for Biden and Trump, as well as the Biden margin. So how much Biden leads versus Trump. It's just the difference between those 2 popular vote estimates, okay? In the EMI book, of course, they talk also about presidential elections, and they have a data set on the 2008 presidential election, which I'm just going to use here because it has some information that we will use that we need, which is specifically the number of electoral college votes, right? So I'm going to go through the same examples and kind of the same code that Imai goes through in his book. But of course, it's much more interesting to look at 2020 election or polling estimates and think about this in the context of this upcoming election. But in order to get this information about the electoral college votes for each state, I'm still going to use this 2008 press08.csv data file that is also discussed in the EMI book. There's more information here. We have, of course, the state names, and we have the actual election result of 2008 in each of those states for Obama and McCain, and we'll use that later on as well as kind of a pseudo validation of our predictions, of course, because we don't know yet how the 2020 presidential elections will actually look like, okay? So how do we compute these electoral college predictions? Ultimately, we need to predict the state level support for each candidate using the polls that we have, the 2020 polls. Then we need to allocate the electoral college votes for that state to its predicted winner. And then we need to aggregate the electoral college votes across states to determine the predicted winner. So who's going to have the majority, or at least 270 votes in the electoral college. And so the coding strategy here will be, for any given state, we have to do the following. First, for each state, we want to subset the polls conducted within it, right? So that's a subset of only polls that were conducted within a given state. And then we want to further subset the latest polls, right? So we could take all polls that we kind of have included in our data set and average across all of them. But what we've seen from past results is that the closer the polls are to election day, the closer the result will be to the actual result that we're interested in, right? So there's an advantage in taking into account only the latest polls that we have, right? So what we're going to do here is we will just focus on the latest polls within a given window. Within a given window before election day, okay? And then ultimately we want to average the latest polls to estimate the support for each candidate. And then, of course, allocate the electoral votes to the candidate who has greater support, right? So that's going to be the strategy. And of course, we're going to need loops here again, but we're going to need loops. And so in order to do this with a loop, we want to repeat this for all states and aggregate the electoral votes. So we're going to need a loop again, but we're going to need more than a loop. We will also need conditional statements. And conditional statements, that's kind of another fundamental building block in programming and that you will use in R. And the basic structure is here that we can have basically a conditional if statement, which the statement itself will be in parentheses. And if the statement is true, then a certain set of expressions is executed. And if the statement is not true, this is where this else comes in, then another set of expressions will be executed, right? So the elements of any kind of if-else construct in R is, well, first the basic structure of having first the if statement, the condition, then the code that is executed if it's true, else then the code that is executed if it's not true. X here is a logical statement that can be either true or false, and then depending on that state we will run one code or the other code. And then these expressions are code chunks evaluated depending on the value of x, right? And again, especially since if we're combining if statements and loops, or multiple if statements nested within each other, indentation is really important to make this code readable. And again, we're going to look at a couple of examples here. As I said, conditional statements can also be nested. For example, we can have multiple conditions. For example, a first if condition, and if this statement is not true, we can add an additional else if, so an additional qualification. If the first condition did not hold, we can look at a second condition, and then have kind of a residual category. If neither of those conditions hold, then execute a third set of operations. And we can nest as many conditional statements as we would like. We could also have if conditions within an if condition itself. And so, as you can see, this is the basic structure is fairly simple, but ultimately it allows you to create fairly complex structures and solve quite complex problems in your computations. So here's just an example of a conditional statement within a loop. I'm just going to go through this fairly quickly. Again, we first have a vector of values. This in this example is just a vector from 1 through 5. We have n as the number of elements in values that we save, and then we create a results vector, which is just of the same length, so length n. 5 elements, and they're all missing, and all we want to do in our loop is replace each of those missing values with some operation that we computed, okay? And so then we start a loop that ranges from I that has the counter I that ranges from 1 through n. And we have a couple of operations here. So in each iteration, we will create a new object called x, which is takes the values, the ith element of the values vector, and then we create a second object r, which is just the remainder when x is divided by 2, and this is what the percent is. It's an operation. It's the modulo operation, which tells you the remainder after dividing by the second number here. Okay, and so why do we need this? Because ultimately here in this specific example, we want to write a function that takes two numbers, or takes one number, and if that number is even, it will add this number with itself, and if the number is odd, then it should multiply both numbers, or the number with itself, right? So we have an if condition here, if r is equal to 0. So that means the value x divided by 2 the value x divided by 2 has a remainder of 0. That means x is that means x has to be even, of course. And then we have an output that says x is even, and I will perform addition, and then we're saving that in the results x plus x. And then else, if r is not equal to 0, that means there is a remainder after dividing by 2, which means the value itself is not divisible by 2, and that means x is odd, and the function therefore performs multiplication and multiplies x times x. Okay, so that's the basic structure. The output, of course, will here, if we go through from 1 through 5, it will say 1 is odd, I will perform multiplication, 2 is even, I will perform addition, and so on. And these results would then be 1, 4, 9, 8, 25, and so on. Okay. Of course, yeah. Okay. Here are the results. If we kind of look at the results after running this loop, we have 1, 4, 9, 8, 25, which is kind of the result of these operations, right? So as you can see, loops are a little bit tricky, so they need a lot of practice, and I really encourage you to kind of go through these examples by yourself in our Studio Cloud and make sure, maybe change them up a little bit, maybe try, come up with a different loop example or different inputs, and make sure to kind of get a good understanding of the underlying structure, because that will be helpful going forward. Again, as I emphasized before, indentation is really important, because here, as we kind of include a loop or an if condition within a loop, whenever we're kind of within a specific condition, a specific if condition, or within a loop, we always move the indentation one further to the right, and that helps us kind of directly see visually which operation belongs to which loop or which if condition. Again, when we're kind of writing up this code, as we start, the best advice is to kind of start without the loop first, setting the counter to a specific value, make sure the code works, and then putting it in the loop. And as always, printing out iteration number and the object inside a loop will help you with debugging. All right, so now we want to compute electoral college predictions, and so let's get started with the polls 2020 dataset. There are a couple of let me see actually. No, there's a little bit. I jumped away. Okay, sorry, there was a little bit of a gap here. Okay, so but before we start, computing our electoral college predictions. There are two things that make this task a little bit more difficult with the 2020 data that we have. Specifically, there are many national polls that can't be attributed to a specific state. So if we look at the states, the state summary in our polls 2020 data, we have 419 polls that are not attributable to a specific state, but rather that belong to, or that were conducted nationally, right? So that's a little bit of a problem when we want to predict the electoral college vote. Another more a bigger problem is that some of the states are actually missing in the polling data. So for some of the states in 2020, we don't actually, at least in this data set, don't actually have polling data that was conducted just for that specific state, right? And so we have, for example, DC, Wyoming, and other states, Arizona, Arkansas, Illinois. We have no polling data in this data set, right? And this is not my doing. If you download the data, you'll see that it doesn't include polls for those specific states, right? So that means we ultimately have two options, all right? What are we going to do? The first thing we can do is we can just drop the states without polls and compute electoral college predictions without including those states. Of course, that could lead to predictions where both candidates have less than 270 votes in the electoral college. So that seems not ideal. The second option is to use national polling averages as a proxy for the states where you don't have individual polls. Now, the disadvantage here is that can definitely introduce potential bias, right? States like Wyoming or Arkansas might have a clear potential political bias in one direction or another. And so using the national polling average, specifically the polls here that were not conducted in a specific state, as a proxy can bias results one way or another, right? So we're going to look at both here, but we're going to focus first on using this national polling average as a proxy and going from there, okay? So how do we get the poll predictions for each state? There are a couple of steps that we have to go through. First, we want to create an object that consists of the state names, which the loop will iterate through. So this is now just all the states that are included in the Press 08 data. So that's all states plus DC that belong to the Electoral College. And then we want to initialize a vector placeholder that will contain our results, right? So that's our result vector that just consists of missing values and has the same length as the state names. And then we're going to add labels for easy interpretation later on. So the names of poll.pret will be the same as the names that are in press in the state names vector, okay? And then we want to loop across, ultimately we will loop across all 50 states plus DC, but when it comes to actually running, actually averaging polling results, we will only focus on the 45 states that were actually had state polls, right? So the loop starts with our counter I from that starts with 1 up to the length of poll predictions. So that's up to 51. So the 45 here is inaccurate. It would be 51. And then we need two if conditions, because we have two different cases, right? One, we have the 45 states for which we have state polls. So we want to compute the polling average for those states. Or for the remaining 6 states, or 5 states plus DC, we want to use the national polls as a proxy, right? So that's an if condition. The first, the way to kind of determine whether the state name that specific state name is part of our is included in our polling data, can be determined by using the %in command, which basically is true if the object on the left is an element of a set of objects on the right? So if state names of in iteration I, so that's one specific state, is part of the all the states that are in polls 2020, then we execute this code, which means we set the state data as the subset of polls of 2020, where the state is equal to the specific state names in iteration I. If this is not the case, that means that the state name is not included, or the state itself is not included in our polling data. We will instead not use the subset for polls of that specific state, but rather we will use the subset of polls that were done nationally across all states. So that's where the state is equal to this 2 dashes. Okay. Then after we've done this, we have our subset of state data, again kind of splitting up the 45 and 6, for which we don't actually have the polling data. And then we subset the latest polls within the state. So we kind of look at the minimum, the latest polls, which is the minimum of state data dollar days to the election. And we select all polls that are basically that were conducted within 7 days of the latest of the that were conducted up to 7 days before the latest poll that was conducted before the election. Okay, so we go up to 7 days back beyond the latest poll in that given state, and then compute the average of the latest polls. We directly use the margin and average it, and that is the result that we save in poll.pred I for the ith iteration. Okay. So that basically is enough for us to compute the electoral college results. Let's see. And of course, we don't know, compared to the example that in the EMI book, we don't know how the 2020 election will actually turn out. But for this purpose, when we want to talk about validating our predictions, suppose this is already post November 3rd and we knew the 2020 results, right? And because we don't have this data, but just hypothetically, in our example, since we already have this 2008 electoral vote data, suppose the actual election results were equal to the 2008 results, right? So if that was the case, if we knew what 2020 will look like, and if it just happens to be equal to the state results in the 2008 election, we could, compute the margin in the 2008 election by looking at the difference between support for Obama and McCain. And then we could actually look at the prediction error, which is the difference between the actual outcome and our predicted outcome. And so that would be, of course, the Pres 08 margin minus poll.pred, which is the prediction that we computed previously. And again, we want to add these the state names to this vector, right? If we want to look at the mean prediction error, we can just compute the error, the mean of those errors, and this is actually very small. Remember, these are percentages, so between 0 and 100, and so we see that assuming that the 2020 results were equal to the 2008 results, our prediction when it comes to average support across those states is about less than 1 percentage points off from the 2008, or from the hypothetical true result, right? So if things go the way 2008 went, then we predicted it very well. Obviously, we don't know whether that will happen, but maybe after the election we can go back and actually kind of validate how well this prediction actually was. That I think that might be an interesting exercise. We also talked about the root mean squared error, and if we want to compute the root mean squared error, so the average deviation from the true value in our prediction. That's the square root of this the mean squared error, of course, and that's about 16 percentage point, right? So on average, our prediction deviates by 16 percentage points from the actual result, like the hypothetical actual result. And so that means, of course, while the average prediction, is not so biased, of course, or when we kind of average it across all states, the bias doesn't seem to be any strong bias, but there is quite some deviation between states. The average deviation is 16 percentage points. That's quite large, right? So if we want to examine kind of the distribution of poll prediction errors, one way to do that would be to look at a histogram of these errors. And this is just a command to create this histogram. And we see that the poll prediction error is the range of errors is actually quite large. Up here for a second, and so we see some states where we actually have the error in predicted Biden's margin is around 70 percentage points higher, or 50 percentage points lower, which is of course extremely large, but there's an explanation as to that's not what I wanted to do. I want to move myself down again. Of course, there's a reason as to why that is the case. To kind of examine why that is the case and why we have these extremely large deviations, we can look at a state-by-state prediction error. We're creating just a scatter plot for poll predictions between the 2008 margin, which we kind of use as hypothetical election results, and the poll predictions that we computed, okay? And we add a couple of additional horizontal and vertical lines here. And so this is kind of the result that we see. Now, this would be more informative if we actually already knew the 2020 result, but we just used the 2008 results as our pseudo validation method. And we can directly see that this is also where these huge deviations come from, right? So remember, for all the states for which we didn't have actual polling data included in our data set, we just used the average poll, average poll results as a proxy, right? And so the average margin for Obama right now is around 10 percentage points here. And so for all these states which are on this line, those are the states where we didn't have specific state-specific polls. We just assumed that they will be, in terms of their support, just like all the other, just like the national average. And of course, that creates huge deviations if we then compare it to the actual 2008 result. The underlying reason here, for example, is that DC has much higher support for the Democratic candidate in 2008 than the national polling average, or Wyoming had a much lower Democratic support than the national polling average, right? So that's where these deviations are coming from. If we just focus on the states where we had actual polling data, we see that these predictions are actually, quite in line with what we see, or what we saw in 2008, and now what we kind of assume, just to kind of go through that exercise, if this was hypothetically the true result that happened in 2020. We'll see how it turns out. If we have some time later on, after November 3rd, maybe we can look at the actual performance in a little bit more detail. Of course, we don't want to kind of stop here. Ultimately, what we want to let's see. Ultimately, what we want to predict is not the vote share in each state. We want to correctly predict the winner of each state. And so if we look at just the 2008 results, which we use as the kind of baseline of comparison here, we can look at the presidential, the electoral votes where the margin was larger than 0. So that's kind of all the states that voted for Obama in the 2008 election. So that's 364 electoral votes. If we use our polling predictions and combine the electoral votes of all polls of all states where Biden now has a lead in the polls, we come to a fairly similar result: 360 votes in the Electoral College. So our prediction, based on the polls that we have right now, would be that Biden will win a majority in the Electoral College. And now note that a big issue here was this assumption that a lot of the states for which we don't have polling data would ultimately just behave like the national average, which of course, if we look at Wyoming and DC, is not the case, right? So what would the poll prediction look like without these missing states? We just include an additional condition here and just select only the states that are actually included in our polling data, and then combine all the electoral votes for those. And we still get to a number of 315 votes in the Electoral College, which is still more than the 270 required. So our prediction is still that Biden will win a majority in the Electoral College. Now, what we haven't talked about is how much uncertainty there is, and we haven't really talked about how these polls differ in sample size and taking that into account and all these things, which goes a little bit beyond what we have covered so far. But if you're interested in kind of going more into kind of the sophisticated details of kind of getting to these polling predictions, check out the methods section in the Economists on this Economist website. In general, whenever we have a kind of the prediction or a question where we want to predict a binary outcome, this is in general a classification problem. And one thing that is important to keep in mind is that whenever we're thinking about wrong predictions and misclassifications, there are different ways we can ultimately get this wrong, right? So there's this distinction between a true positive, where we're correctly predicting the winner, false positive, where we're incorrectly predicting the winner, or incorrectly predicting, in our case, Biden to be the winner, or positively correctly predict, or true positive correctly predicting Biden to be the winner in a given state. Or on the other hand, true negatives, so we're correctly predicting the loser, and a false negative, incorrectly predicting the loser, right? So those are slightly different ways of getting the prediction wrong, and these can be important to distinguish, because sometimes false negatives are more or less important. So for example, when we were thinking about predicting civil war, we might be more concerned with false negatives, as in falsely predicting that a civil war will not happen, and then it does happen, is much more consequential than falsely predicting that a civil war doesn't happen. The other way around. Falsely predicting that a civil war will happen and then it does not happen is not as consequential as falsely predicting that a civil war will not happen and then it does happen, right? So in that sense, the false negative is much more important, like, from a policy perspective, because we're much more concerned about the false prediction that the civil war wouldn't happen, and then it turns out to happen, than the other way around. So these kind of different types of misclassification are really important to kind of keep in mind. Other examples are, for example, if you think about, I don't know, COVID-19 tests, right? There's clearly a difference between or concern about kind of a false positive rate versus the false negative rate, right? To what extent are you concerned about falsely getting a test that you have COVID but then you didn't, versus getting a test that says you're negative and then actually you're still spreading the disease, right? Obviously, we're more concerned with the false negatives when it comes to these tests, for example, right? In general, when we talk about the accuracy, what we mean is just the extent to which the prediction lines up with the actual result, right? So in our case, if we want to compute the accuracy, we can use the sign function, which returns a 1 for every positive number, -1 for a negative number, and 0 for zero. And so this function is really useful because it can help us to just say, look at the average of cases where the sign in our polling prediction is equal to the sign of the margin in 2008, and we see that in 86% of the states, the prediction is consistent with the actual vote margin, or the actual winner in 2008. Okay, we can also look at which states which states are deviate between the results, and again, we see here that we're especially wrong for states where we didn't actually have polling data. So Wyoming and Arkansas I mentioned previously. So those are states where the poll prediction that we computed, because we didn't have actual state poll data, deviates from the margin in 2008. And we can, if we want to kind of see what the actual margin was for these states, or was in 2008 at least, we can select those specific margins by selecting all cases for which the sign of of our prediction was not the sign of the margin, and then we get the actual margins for these states. Okay. This was a rather long video. In the next video, we're going to talk about linear regression.